Okay, good day. This is Honors Algebra 2. I am Mr. McCulley, and this is the presentation for section 12-2, radians and angle measure. We made it. So let's get right to it. Today we are going to define an angle in the standard position, and then we're going to convert between degree and radian measures of angles. This shouldn't be too bad. First, definition: an angle in the standard position. It has its vertex at the origin of an xy plane. Its initial ray lies on the positive x-axis, and its terminal side opens positively in a counterclockwise direction and negatively in a clockwise direction. So, if we are talking about this particular angle right here, its initial ray is going to be the positive side of the x-axis. That's where it's always going to start. And then if we open counterclockwise, we will go in the positive direction. And if we were to open counterclockwise, so we're always going to start here. And if we go this way, we'll open positively. And if we go that way, we'll open negatively. The terminal ray is where it ends. So it always starts along the x-axis. It opens either counterclockwise or clockwise until we get to our terminal ray. Definition: two angles drawn in the standard position are coterminal if they have the same terminal ray. So if I grab, let's see here, let's grab an arrow. Let's change it smaller. Let's make it red. And we start here with our first angle. We can have a coterminal angle if we start here and move negatively to this portion right here. Let's say, just as a for instance, that this is negative 225 degrees. Or if we start in the standard position and open positively that way, this angle would be a positive, let's see here, 135 degrees, and 225 and 135 equal to 360, so that looks right there. So we have two coterminal angles. As an example, find two angles, one positive and one negative, coterminal to 60-degree angle. So let's just real quickly draw something in like that real quick. And so a 60-degree angle is going to look something about like that. And this is 60 degrees. And so if I make one positive, well, here's how I'm going to do the positive value. I'm going to start in this standard position. I'm going to go past the original, and then I'm going to go around until I get back to that original. So this first revolution is 360 degrees, and then an additional 60 degrees to get to the end. So a positive coterminal angle can be found by taking the angle theta and adding 360 degrees. So in this case, we're going to have 60 plus 360 is going to be 420 degrees. There's our positive. The negative coterminal angle we will start in a negative or start in the standard position, but instead of opening positively, we will open negatively. Now, this red angle is 60 degrees from being 360 to the negative, or negative 360. So how am I going to figure that out now? I am going to take theta, and I'm going to subtract 360. And again, this is provided that theta is between 0 and 360 degrees, provided that that's how that one's going to work. So in this particular instance, we'll get 60 minus 360, which will give me negative 300 degrees is our negative coterminal angle. And that's it. All right. So, definition: a radian is a unit of angle measure related to an arc length. One complete revolution is 2 pi radians. So you're used to measuring angles with degrees, and radian is another way of measuring. So you think of radians, degrees in a similar way to the way you think of yards and meters. All right, they're measuring the same thing, but they're different lengths. All right, so on a number line, if we start with 0 degrees and we go all the way around the circle, we'll have 360. There are corresponding values for radians. Radians starts with 0 radians and goes up to 2 pi radians. All right, so and we know that pi is 3.14, and so even though this is only 6.2-ish, right, we can still, because this is an infinite number of values, this is a continuous list, we can actually match these up 1 to 1 and still be okay. So halfway, a half circle is 180 degrees, a right angle is 90 degrees, and 3/4 of the way around would be 180 plus 90, which would be 270, and then that third quarter, another 90 degrees, would be 360 degrees. So for radians, we're going to have matching values. So if for 360, I divided 360 by 2 to get 180, 2 pi divided by 2 is just going to be pi radians. And then if I divided that in half to get 90, pi divided by 2 is just going to be pi divided by 2, which we'll call pi over 2 radians. And so this one right here is going to be halfway between these two. But if we think about it this way, I'm counting 0, pi over 2, 2 pi over 2. This will be 3 pi over 2. And then 4 pi over 2 would cancel. 4 divided by 2 is 2. And so these are our matching radian measures. All right. If I wanted to convert from radians to degrees or from degrees to radians, I'm just going to use this equation. It is just a conversion factor, kind of like there are 4 quarts in a gallon kind of a thing. And if I want to convert radians to degrees, I'm going to multiply by 180 over pi. And if I want to convert degrees to radians, I want to multiply by pi over 180. All right, so let's do a couple of examples here. I want to convert these following from radians to degrees or degrees to radians. And so since I start with a degree question, we'll have degrees to start. And so I am going to say that I have 60 degrees, and I'm going to multiply that by 180 degrees over pi radians. Now, I don't want to simplify that, and we could do it in our head, but just to keep things easy, we could go to our graphing calculator and go 60 divided by 180, hit math, hit the fraction, and that'll reduce down to 1/3. So the 60 over 180 reduces down to 1/3. All I have left is this pi. So this literally becomes 1/3 times pi, or pi over 3 radians. We can do the same thing with this one. We'll go 270 times pi radians over 180 degrees. And so if I go 270 divided by 180, hit math, I hit the fraction, I get 3 over 2, and I still have the pi, so it's 3 pi over 2 radians. And then if I have 2 pi over 3 radians, well, I'm going to use the radians conversion factor. And that one will give me 2 pi over 3 radians. And then I'll go pi radians over 180 degrees. And the pi's will cancel. So it's just 2/3 of 180. So if I go to my graphing calculator, I go 2 divided by 3 times 180. I get 120. So this is 120 degrees. Same thing here with a negative. I go negative 3 pi over 4, and then I got 180 degrees over pi radians. The pi's cancel, and so negative 3/4 times 180, negative 3 divided by 4 times 180 gives me negative 135 degrees. Finally, the arc length, S. For a circle of radius r, the arc length of an intercepted central angle theta is S equals r theta. So if they give you this r, they give you this theta. Again, r must be in radians. All right. R must be in radians for this to work. There's another equation for degrees. It's a little bit more complex. But it says, what is the arc length of a circle with radius 4 inches and intercepted arc of pi over 3? So just real quick, if I have a circle here, and I know that from here to there is 4 inches, and I know that the arc that is being intercepted here is pi over 3, then the value S here, S is equal to R times theta. S will be equal to 4 times pi over 3, which will give me 4 pi over 3 inches. And you can leave it like this, or if you don't like that, you can go 4 times second pi divided by 3 and gives you, let's see here, 4.189 or 4.189 inches. All right, that's all I got for today, folks. So the McCulley fun fact of the day, Mr. McCulley's first full-time teaching position was at Fremont Middle School in Fremont, Ohio. It was a city block. It had 1,200 students. It was a fairly rough crowd. That building doesn't exist anymore. They demolished it in 2012. Anyways, while I was there, I taught citizenship and proficiency skills to help kids with the proficiency skills test. That's all I got for today, folks. Have a good day. Bye.